So we're going to look at one more form of way to describe a shape, and there are two things we can look at when we look at shapes. We can look at lines of symmetry, and we can look at rotational symmetry. So lines of symmetry and rotational symmetry. And you've probably covered this before, but this is basically when we're talking about lines of symmetry, we're thinking about, okay, where can we put a line through an object where it will fold over onto itself. And so when we're looking at this hexagon here, whoops, my line doesn't want to work out so well. Whoops, I lost everything. Let's go back. There we are. I lost my line. Okay, so we draw a line through it. And if we draw the line through there, we know one side can flip onto the other. So we can actually go from any vertex. Remember, a vertex is where two line segments meet. And now we have three lines of symmetry. But that's not it. We can also go to the midpoint opposite, on opposite sides, and we can create three more lines of symmetry. So there are in total 6 lines of symmetry for this regular hexagon. What about rotational symmetry? That's if we clear off this page. Let's get a hexagon up here, a regular hexagon. And here's our regular hexagon. And we're going to ask, well, how can we rotate that? How many times can we rotate it so it lands upon itself? So let's first of all change the colors so we can identify this one. So the starting point, here we are. We're going to rotate it. We rotate it like this. It lands on itself. So that's what's called the 1 degree of rotational symmetry. But we can also rotate it a second time. That's a second time, and it lands upon itself. Third time, fourth time, fifth time, and then the 6th time, it's where it started, where that little green circle is on top. So this shape has 6, we would say, degrees of rotational symmetry. Or rotational, the other way you can say it is rotational symmetry of order 6. Those are just the ways that they say that. So 6 degrees of rotational symmetry or rotational symmetry of order 6. And every shape, if you think about it, has rotational symmetry of order 1. If you take any shape and you have it go 360 degrees, it's going to land on itself. So if we look at a random shape like this, even a very irregular, odd shape, if we take that shape and let's clone it, and we turn it onto itself, well, it's not going to rotate anywhere here. Nothing's going to work until we get all the way 360 degrees back to the beginning. So that shape has rotational symmetry of order 360 degrees. But we can look at some other shapes and see what happens here. So we've got, let's say, an equilateral triangle. Let's clone that and see how many degrees of rotational symmetry it has. And let's pull it up here. And we'll rotate once. I'll have to move it a little bit. And we'll rotate twice. And this is not lining up perfectly because it's not rotating from the center. And we'll rotate 3 times. And you'll say it does have, in this case, 3 degrees of rotational symmetry. How many lines of symmetry does this equilateral triangle have? Well, we can go from each vertex through to the midpoint of the opposite side. That's one line of symmetry. Here's another line of symmetry. And there's a third line of symmetry. So an equilateral triangle has 3 lines of symmetry, as well as rotational symmetry of order 3.